Okay.
So hi, everybody. Thanks for being here. This is the Pathways presentation for ECE students curious about graduate programs. And we have a couple of grad program chairs who you'll be introduced in just a moment, but this is mostly going to be led by our graduate program manager for advising and all things graduate program for us, Lynn Pratt. So Lynn, go ahead and take it away. Thanks for being here, everybody.
Thanks, Bob. So many of you should be aware that grad school exists. That should not be, I know, Dr. Kazicki surprised. He just learned. So everyone should be aware that it exists. You might not be aware of all the options that we have for you. So today we want to talk about graduate school, options other than graduate school, all of our programs, and some of the 4+1 options. Jaya is our 4+1 coordinator, and she also has separate webinars that go into more detail. So today's going to be a very quick overview on all of our programs and why graduate school might benefit you.
A stairway to graduate school, if you will.
What? Did you make a joke I didn't get?
Yeah, I said this would be a stairway to graduate school, if you will.
Bob, you're fired.
You have to be of a certain age to understand that one, Lynn.
And I'm not.
That was a backhanded compliment.
I am. I love it, Bob. Great one.
I love reminding our faculty of how young I am because it horrifies them. We are going to start off with hearing from Dr. Kazicki, Graduate Program Chair for Electrical Engineering, which is the direct continuation from your undergraduate electrical engineering program. Dr. Kazicki, do you want me to do the slides?
Oh yeah, that'll be fine. That'll keep it.
Or you do it.
That'll keep it nice and smooth if you do it.
Okay, you got it. Let me get this going.
Thank you so much. Right. So good morning, everybody. It's a great pleasure to be talking about our graduate programs with you. As Lynn mentioned, I'm Michael Kazicki. I'm the graduate program chair for the electrical engineering stuff. You'll see, we offer quite a range of graduate degrees, under the ECE umbrella. But I'll be talking about the electrical engineering stuff today, our masters and our PhDs. All right, Lynn.
Oh, look, it's you.
That's me, very handsome. I mean, someone will be this bright and this handsome, I've no idea, but I am. What can I say?
You're truly God's favorite.
And indeed, what can I tell you? What can I tell you? As I say, I'll be talking just a little bit about the master's and the PhD. So, all in all, under ECE and what you'll be hearing about later today is this vast panoply of offerings that we have. I mean, clearly, we're a very technologically diverse school. We've got a lot going on under the umbrella of electrical engineering. In addition, of course, to our MSc and MS and PhD degrees in electrical engineering, we're hearing about computer engineering and our robotics and autonomous systems and I guess DSE is DSE AE in the okay.
Yes, I just keep forgetting to add it.
Fair enough. That's great. Yeah, no problem at all. We'll be hearing about that. Next slide, please. We do have, and I think most of you are probably aware of this, but I'll make sure you are if you aren't. Under the masters, we have the MSc and we have the MS. Now, the MSc is our, basically, 10 classes of graduate level work, and there's no thesis involved, whereas the MS, without the E at the end, does have the, in essence, 6 hour of thesis thrown in there as well. A lot of people have been asking, I guess, about the difference between these two. I mean, they're both excellent degrees. They're both very much professional degrees within our profession, meaning that they're a very, very good path onto higher and higher levels within the engineering profession. Typically speaking, the MSc with all the classes and no thesis is a much quicker and kind of cleaner way to get through the program. I think it's safe to say. Whereas the thesis option, I mean, clearly you're going to have to do something that's unique that's researchy, research oriented, you know, has an actual you know, practicum component associated with it. It tends to be more for people who see research in their future, maybe even want to kind of dip their toe in the water prior to transitioning into a PhD, for example. Speaking of the PhD, of course, that is our, you know, kind of like crowning research achievement degree, where obviously there's a few classes involved in there, but it's mainly doing unique, world-shattering research where you become a world expert in a particular topic under the guidance of a committee chair and a committee of faculty that help you through. Okay. We do have, you know, under electrical engineering, I'll talk about the kind of specialties under there. In addition to the graduate degrees under electrical engineering, I should mention that you will have the, is that the right name for it these days, Lynn?
The EE, MSc, and MBA program, which is concurrent 2 degrees.
Oh, that one. Yeah, I was looking at the media arts and sciences.
That is their brand new name.
That's the new name. I always get, because they change things on me, and you should never change things. You know, and I get, you know, old men like me get really confused when you change things. So they change the title here, but obviously that program with its master's and PhD under media arts and sciences does involve a combination of arts and media type of stuff, along with you know, kind of electrical engineering components. So that's a really interesting one. And as Lynn mentioned, we still have what used to be many years ago called the Tech MBA, where there's a concurrent, you know, EE, MSc, and MBA that you can take essentially in parallel, and that, as mentioned there, is online only. So these are kind of some of the specific degree options that we have under the electrical engineering umbrella. Right, Lynn? All right, some very basic requirements, and I'm going to say this at least 3 times so it sinks in. I really encourage you, if you're interested in graduate school, to check out our graduate program guide. We'll talk about that in a little while. It's extremely important. It has all the rules, some dating back to, I believe, the Roman era. They're pretty ancient and pretty important that you know about them. For example, if you want to get an MSc, you have to do 10 classes. And that means 10 classes. It doesn't mean 10 times 3 equal 30 credit hours. It means 10 classes. Now, there is a distinction there, because some classes may be 4 hours, as an example. So you just have to make sure you follow that. Obviously, on top of that, we've got our PhD, and you'll do another 6 classes, and you know, along with whatever you've done for your master's. And if we can move on to the next slide, Lynn. You know, obviously the big question is, well, which classes would you take? Which classes would you choose out of those 10 plus 6? You do basically what you want. I mean, within certain guidelines, you can't do, you know, 28 credit hours of underwater basket weaving. And I mean, they clearly have to be relevant to the profession. But it really, this is one of the great things about graduate school, is it's very much, you know, build your own pizza kind of thing. You choose what you want to take. Now, obviously, if you're interested in a particular area in electrical engineering, you heavily load it up with classes from that area. Okay, and if we can move to the next slide, please. So start with your areas of specialization, but don't just stay within those. You know, you can take additional classes that can help expand your mind a little bit. But clearly, you know, you're going to go with your specialization for the bulk of your classes. Next slide, please, Lynn. And the specializations look like this, or at least our traditional specializations, where we've got the mixed signal and circuit design. So clearly all the kind of circuity stuff is in there. Electrical power and energy systems, which is a very strong area here at ASU, which, as the name suggests, is more on the, you know, power engineering side. Signal processing communications, again, fairly obvious what that is. Electromagnetics, antennas, microwaves, again, very obvious. You know, a lot of antenna stuff, solid Maxwell's equations stuff in there. Physical electronics and photonics is maybe a little more obscure in terms of title, but that obviously is, materials, processes, and devices in microelectronics and optoelectronics. And then we've got control systems. Again, that's a fairly obvious title there. And these are the kind of specializations you might want to get for your master's or your PhD as far as the coursework is concerned. But we always encourage people to build their own core in these specializations, but have classes that expand your mind beyond that. So classes even outside of electrical engineering are encouraged too. Next slide, please, Lynn. All right. We do remind you, I think we remind folks coming in as first years all the way through to people coming up to their PhD. It's very important to understand that, in electrical engineering, you may be specializing in a particular area, like antennas or like, solid state devices or circuit design or whatever, but you will be working in multidisciplinary teams, and it's a really, really good idea to understand how all these different areas work together. And that's why we really encourage you to take a few classes outside of your specialization. And, the example we always give is, you look at a cell phone and it's not just one area of electrical engineering. It's literally all areas of electrical engineering thrown in there. Next slide, please, Lynn. Graduate handbook or online handbook. I think we'll be posting that link a few times today. Please look at that before you get into this, so you know what all the rules are. Another important thing is our school webpage. If you look up, faculty interests there, you'll see the kinds of things that the faculty are doing research-wise and what their interests are. So that helps inform you what kind of courses you want to take, and indeed who you might want as a supervisor during your MS or PhDs. Obviously, make sure you understand prereqs. We do have a lot of prereqs for courses. Not all of them, but some of them have pretty strict prereqs. 425 is a big one there. You can plan accordingly by building your course schedule. And our advisors are the best advisors on the planet. I will put in a plug for them. I have never seen advisors so competent, so friendly, and so useful in all my days in academia. So please make use of your academic advisors and your graduate advisors. They're tremendous. Next one, Lynn, please.
You're done.
Great. Awesome.
Well, thank you so much, Dr. Kazicki.
Welcome.
So next we're going to hear from Dr. Aberly, who is going to give you another perspective. You've just heard about grad school. Well, what else other than grad school? Dr. Aberly, take it away.
Well, thank you, Lynn. And I want to also second Dr. Kazicki's endorsement of our advising staff. They are really, really good. And I'm not just saying that because
you're scared of me?
Are here to hear me, but because it is really true. They are absolutely wonderful, and take advantage of them. Use them to assist you as you move forward with your decision, if you would, to continue your education. So I'm going to kind of play devil's advocate here and ask you a question. Do you really want to be an engineer? Certainly, if you're in a BSEE program, you should finish it, but be aware that that doesn't necessarily mean that you are pigeonholed into being an engineer. There are a lot of other options. And I'm also going to tell you, like Professor Kazicki, I am also an old man, and I can tell you that life has, it seems like yesterday I was just 22 years old, and today I'm, thinking about retirement. So, life is short, and you really need to be doing something that you enjoy, especially if you're going to be doing it for, many decades. Once you complete your BSEE degree, you have a lot of paths to enjoyable work opening to you. Now, I, like the other faculty here, have a knack for engineering. I mean, I knew from like the age of 12 that I wanted to be an engineer. And that's great. And many of you probably do as well, and that will be wonderful. But other people may be pursuing an engineering degree for other reasons. So, your high school counselor told you, hey, you're good at math and science, you should go into engineering. It's a lucrative career. So if that's the case, and you're not really sure if this is what floats your boat, then you might think about doing something else. And I know plenty of folks who've gotten degrees in electrical engineering or other engineering disciplines and have gone into other, somewhat related areas, perhaps. One, at one time, being an intellectual property lawyer was a very lucrative career path. And I know several intellectual property lawyers, good friends of mine, who've done quite well for themselves and have very interesting jobs. And they use some of their engineering background and they get a law degree and have a lot of interesting and in many cases lucrative careers. I know one guy who got a PhD in electrical engineering and later became a criminal defense lawyer. I think the ability to think critically and to understand concepts is very helpful for, if you decide to pursue that end of things. I know folks who've gone from getting a BSEE and become medical doctors. I've worked with medical doctors with engineering backgrounds, and they understand things about medical devices and imaging and this sort of thing. And they have very interesting and make very interesting careers that make great contributions to to the advancement of medicine and help people that need help, etc. I know others who've become venture capitalists. So in order to understand some of the whether something's a good investment or not, especially in the tech world, you need a background in engineering. And again, that can be a very interesting and lucrative career, perhaps the most lucrative of them all. Some electrical engineers move into science. Physics, our School of Earth and Space Exploration, has several examples of their faculty who got undergraduate degrees in electrical engineering and then moved more into the science area, especially radio astronomy and understanding, very fundamental things about the universe. And then others, some people, work really well with other people and can direct them and manage them. And so many become managers of engineers, for example, by earning a master's in business administration degree. And we, of course, Professor Kazicki went over the ability, I think he mentioned the degree where you get both an MSE and an MBA degree simultaneously. That may be a good career choice for many of you. Let's talk about what advanced degrees an engineer might get. One of the, of course, there is, why isn't this working? Wow. You guys can hear me, right?
Yeah.
Okay.
Yeah.
So let me get out of this. You know what? I wonder if it's because I shared and only shared the first slide. Some of you may want to help, work on making effective presentations for others. Okay, so I think you can see it now, right?
Yes.
Okay, so we're improving the software that we use for presentations. So I think if you do decide to get an MSE, for example, I really do think a master's degree, especially in this day and age, is essential for remaining in a technical path. if you really like engineering and you think that that's, you want to make your career simulating and building and, analyzing and being responsible for product development, I think master's degree is absolutely essential. PhD degree is the only career path for which that is really essential is an academic career. There are companies, and Intel is a good example, where it can help with career advancement. But for the most part, a PhD degree is you become the world expert in an extremely narrow area. And it's very likely that, a decade from after you complete it, your work will be obsolete. That certainly happened to me. But the idea is that it opened up a path for me that I wanted to pursue, namely academia. Some engineers, some with BSEE degrees, move into another engineering or science discipline. This is a real possibility for those who find that maybe mechanical engineering or radio astronomy or other area may be of more interest to them. So I think once again I've froze up here. Another thing is, if you want, many engineers decide that, I like engineering well enough, but I would rather guide others as they do the nitty gritty engineering stuff on a day-to-day basis. And for those folks, perhaps an MBA is an appropriate advanced degree. In any case, if you have the ability and the desire, I do recommend getting an advanced degree and doing so in an area that is of great interest to you. If you feel that electrical engineering, it's fine, but I don't get up in the morning really excited about the work I'm doing, you may want to leverage your degree to pursue another path. But if you really do like electrical engineering, then I strongly recommend a master's degree and consider that a real necessity for continuing on a technical career path. And that's all I've got to say, guys. Thanks.
Thank you, Dr. Averly. Next up, we're going to hear from Jaya about the Accelerated Master's Program. You might see it referred to as 4+1 or Accelerated Masters. They mean the same thing. As we've just heard, master's degree is a must for a technical path. That's exactly what Dr. Averly said. It is going to directly benefit you. Going through the Accelerated Master's Program, you're going to earn it faster. Jaya is going to tell us how. And that means you're going to start earning more money faster. I believe the salary difference between a student with a bachelor's degree and a master's degree in electrical engineering, I think it's what, Jaya, 20 to 30 grand difference?
Yes, yes.
So you're going to start making more money faster.
Mm-hmm.
And Jaya is going to tell you all the ways you can.
Absolutely. Thank you. I'm just trying to see if I'm sharing the right screen or sharing any screen at all.
Not yet, but sometimes
not yet. Okay. Oh, so here it is. Okay. All right. Can everybody see this?
Yes.
Awesome. Well, thank you. So today I'm going to give you a brief overview of what the Accelerator program is about, because we have less time and there are more speakers after me. So as you heard from the other faculty, there are several graduate program options for you to consider after your bachelor's program. Each of the degrees have specific degree requirements, and most of our master's degrees have at least 30 credits, and some degrees require specifically 10 classes, like the electrical engineering MSc degree. And we now have a new program that we're offering called the Masters in Data Science, Analytics, and Engineering with an electrical engineering concentration. You'll be hearing more about this program shortly. So all of these programs, that is the master's programs, require a minimum of 30 credits, and they have various different culminating experiences, like the seminar portfolio or a capstone or a thesis option. Now, what is important to note here is that the time required to complete a master's degree after finishing your bachelor's is at least 2 years. Now, this is an approximate time, because if you are pursuing a thesis option, it could take longer. And if you are a part-time student, that is, if you're working full-time, it could take longer than 2 years, and because you'll be taking less classes every semester. Now, if you're thinking that 2 years is a long time to invest after 4 years of bachelor's, and if you're wishing that there was a better way of completing a master's program in shorter time, then you know what? There is an option that you should consider, and it is called the accelerated program or the 4+1 program. What it does is it allows you to graduate with a master's degree in a year after completing your bachelor's. So it's exactly as the name says, it's an accelerated master's and bachelor's program. So this program allows course sharing. While you're in your bachelor's degree, you can start taking master's graduate classes, and thereby reduce your total time as well as the cost to completing a master's degree. So how do these classes work? The shared classes, as they're called, are exactly that. Classes taken while you're in the bachelor's degree, you will be taking graduate classes and sharing them between your graduate and undergraduate degree. So basically, you're double dipping some courses, and typically the courses that are shared are the upper division technical electives, the 400 level classes. And these classes can be taken while you're in the bachelor's, and you'll typically be taking a graduate section of the same 400 level class. So these shared classes count towards both your bachelor's GPA and your master's GPA. The reserved classes, on the other hand, are classes that cannot be shared with the bachelor's program, and they can only be used towards a future graduate program. So these classes taken as reserved will not meet any of your bachelor's degree requirements and will not be counted in the bachelor's GPA. They will only count for the future master's program, and the GPA will count only in the graduate portion of the accelerated program. So what accelerated or 4+1 program options are available? Well, every master's program that's offered by the electrical engineering department is available as an accelerated program. So some of the choices are the electrical engineering MSc and MS degree that can be an accelerated program, the computer engineering degree with a concentration in electrical engineering, as well as the robotics, autonomous systems with electrical engineering concentration, and the newest program, the data science analytics engineering within electrical engineering concentrations. Of all of these programs, the EEMSE program is the only online program. All the others are currently offered as in-person programs. So while the number of classes and the degree requirements for each of these programs remain the same, if you notice, the time to complete this degree is significantly reduced. So in the previous slide, we saw it was approximately 2 years. It now becomes half of that, approximately an year or more, depending on whether a student will be a full-time student or will do research as their culminating experience. So how is this achieved? This is achieved by allowing students to share 3 graduate classes while they are still in their bachelor's degree. So these classes will count towards the master's as well as meet bachelor's technical elective requirements. Now, they can also reserve classes, but the number of reserved classes would depend on how many classes are shared. So there is a policy by the ASU Graduate College that has been set to 12 credits of shared and reserved classes. So unfortunately, they don't allow sharing almost all 10 classes or 9, so that you're left with just 1 when you come to the master's portion. But they allow only 3 classes to be shared, and the number of credits is capped to 12. So, for example, if a student is sharing 3 classes and they're all 3 credits, then they are left with the option to reserve one 3-credit class solely for the graduate program. So if a student is sharing a combination of 4-credit classes and 3-credit classes, then they will be sharing about 10 to 11 credits, and they will not be able to reserve an additional class because they'll be very close to the maximum of 12 credits. So that is how this program would work. Now, there are some application requirements for the accelerated program. Each of the programs have a minimum of 3.0 GPA, but some programs require additional GPA, which is slightly higher GPA rather, which is the EE MSc program currently requires a 3.25 cumulative or major GPA, while the CEN EE program requires 3.0 cumulative GPA. The RASE program requires a 3.25 cumulative GPA. I think the data science would be about 3.0. Is that correct, Lynn? Is it 3.0 or is it not set yet?
3.25.
Oh, 3.25? Okay.
Mm-hmm.
So CEN is the only degree that allows a 3.0 GPA. Awesome. So if you are considering this program, then you should start thinking about applying before you start your senior design. So I have more details on how and when to apply. So as I mentioned, the semester before starting senior design is when you should consider this program and start filling out the application. We have a deadline for these applications. So if you plan to share courses in a fall semester, then you should submit your paper application by July 1st to be able to share courses in the fall. And if you are planning to share courses in the spring semester, then by the previous December 1st, you should submit your paper application. Now you can always contact me if you have questions about it. And we also have a detailed web page explaining all of these requirements, and you can find it under degree programs on our ECEE main webpage. I think it is, somebody had put it in the chat, the ecee.engineering.asu.edu. You'll find the accelerated programs under the, on that website. So the application is very simple. I have sample applications as well as details explaining how to share classes. So you list the tentative 10 grad classes that you would take in the master's program. And this should include your shared and reserved classes. And once you've completed the application, there is a email address that you can send it to. You can also send it directly to me. My email is jaya.krishnamurthy@asu.edu, or you can send it to our general email address, which is eceegrad@asu.edu. If you have questions about it, you can schedule an appointment by calling the advising office, or you can go online and schedule it through the advising tool. Now, every spring and fall semester, I have several virtual information sessions about this program. I've had several already, and the next session coming up is on Monday, March 18th. I will be sending out an email with details about the time, as well as if we have a guest speaker who I'm waiting on for confirmation, and as well as all the Zoom links, etc. So in the meantime, if you are able to attend that, that's great. If not, you can refer our website as well as call the advising office, schedule an appointment, and learn more about the accelerated program. And I think that is all I have.
Awesome. Thank you, Jaya.
Of course.
Before we talk about the shared programs that we have, I want to make our students do some math, because that's the type of person I am. Oh, Kaziki's scared. He's probably got to hop off for another meeting right now. Okay, so students, your bachelor's degree is 120 credits. So let's assume each class is 3 credits. How many classes total is that? Put it in the chat or unmute. 40. Yes, Andrew. Perfect. Perfect. So for 40 credits to get your bachelor's, or 40 classes to get your bachelor's, through the 4+1 program, you're sharing 3 classes. So it's just 7 more classes. to earn your master's degree. Just 7 more. 7 more classes seems like a pretty good deal when you consider that you're going to start making 20 to 30 grand higher. Seems like a good investment. So we really want you all to consider this because it is in your best interest. It's just 7 more classes. I know a lot of you are probably thinking, I'm tired of school. I don't want to do any more school. But you might get to a point in your career in which you figure out, I really do need that master's degree. Oh, yep, Andrew's like, I wasn't going to do it. But today, Andrew, you shall be convinced. Master's degree is for you. You're going to get to a point in your career in which having a master's degree might be helpful for promotions, setting you apart from others in the pool. Coming back to get your master's degree after you've been out of education totally sucks and is really hard. Just get it over with, crank it out, and share those classes so you only have 7 more to take. So all of our graduate programs have 4+1 pairings. We heard about electrical engineering earlier. That's the direct continuation on from your current degree. But you know, ASU is #1 in innovation. And one of the ways that we think that we are #1 in innovation is some of our innovative and interdisciplinary degrees. So we have some really interesting degrees that you're going to hear about next that you might not have ever contemplated. So first up, we're going to hear from Dr. Reislein for the computer engineering degree. Martin, do you want to do the slides or do you want me to?
Well, just like Michael, maybe it's best if you run the slideshow. This is smooth as
You got it. I will get that up for you.
All right, thank you. And we can then jump right away into the next slide. So welcome. This is the overview of the CN program, undergraduate program chair, Martin Reislein. I'm professor in the School of Electrical, Computer, and Engineering. My personal research is mainly in computer networks, which actually straddles the areas that we're going to talk about. So the next slide, please. And the two schools or areas that we are straddling here is the electrical, computer, and energy engineering in Goldwater. And then on the other side, the computing in Centerpoint. So those two schools house this one joint program. Administratively, we'll notice if you get into computer engineering, there is a CEN dash EE versus a CN dash CS, which has some administrative aspects to it. You're either being advised through our excellent, as we point out many times, I need to endorse it as well, in that it's very appropriate, and correct our excellent EE advisors, and then on the other hand, through Sky advisors. And you may have heard some horror stories about Sky advising, but I can assure you they're working to improve. They've hired new people, and it is hopefully on the way up. There's a lot of students over there. In that regard, also EE is a much smaller program compared to computer science. So you have more of the personalized hand-holding, certainly in terms of advising in EE versus more of a mass operation in computer science.
Yes,
in any case, we
stole one of their top advisors.
Yeah. We are digressing here a bit. So in terms of topic, there is some. Maybe let's go back just one more time. The topic is so electrical on one hand and computing on the other hand, and there also the CNEE versus CNCS has some implications for the specializations and breadth versus depth requirement you get into once you are entering this program. If you come up through electrical engineering like you do here, it's probably advisable to apply to CN-EE when you apply, versus students who come from a computer science background are probably more advised to go into the CN-CS program because that suits their background better. Good. So then going on the next slide. So CN is a transdisciplinary program. As I said, it's bridging across electrical and computer engineering, and has all these hot topics that we see here: communications, your phones, use extensive computer engineering, and all these things that you have, essentially your supercomputer in your pocket, needs to be very smartly designed, both from an electrical circuits perspective, as well as from the algorithms and computer science operating systems perspective. Because if you're pushing the performance, the very, very limits where everybody wants it to be is a competitive, highly competitive space, you need to jointly design and jointly co-optimize the hardware and the software. They have to be unified and jointly work together in a very optimized manner. And this joint optimization of both the electrical engineering aspects as well as the computer science aspects, that calls for computer engineering. That's where computer engineering comes in. Yeah. So the next slide, please. And you see there are a lot of areas that are surrounding computer engineering. In the core here, you see our 5 CN focus areas. It goes from autonomous systems, robotics, distributed dependable systems, as well as communications networks with my personal research interest. Then you have the signal processing, and then the VLSI embedded systems, where more the circuit side comes in. So surrounding these areas, you see now these application domains. There's IoT, data analytics. All those approaches that are emerging require knowledge from these core areas. And you also notice here that these core areas, again, straddle electrical and electrical engineering, computer science. So the VLSI is more classical EE perspective, versus distributed dependable systems. That's more the computer science perspective. And then you have, of course, areas where, again, naturally electrical and computer engineering, computer science come together. Autonomous systems, robotics requires both computer science and electrical engineering. Yep. Any questions at this point from anybody about this? Because it's very heterogeneous, different from the classical purebred electrical engineering program, whereby electrical engineering itself is, of course, broad, but now we're getting even broader and wider, casting a wider net here. Good. So if no question, then let's go on into how we get into. Oh, well, here's some more pictures to illustrate these additional applications. Of course, the smartphone is very prominent, but then you have also medical domain is very prominent, and then any type of extreme environment, I think from Mars rover, that will push everything to the limit, right? You need to have the hardware and software closely cooperating and jointly optimized to work efficiently in these extreme environments. All right, next slide, please. So what programs do we have? We start off here, of course, with a master's program as well, but I want to entice you here to consider seriously the doctoral, the PhD program. Our PhD in computer engineering is very highly research focused, a bit more so than the electrical engineering program PhD is. We have the so-called reading and conferences. These are independent studies that you conduct with your research advisor, and these are tailored to bring you very efficiently, very rapidly to the specialization that you're working on. Yeah? So you can tailor, very, very carefully tailor and very narrowly tailor your program, your coursework towards your research. And ultimately, the PhD is a research degree. So anything that helps to be productive quickly in research is helpful. And therefore, we are very, very proud of our CM PhD program, because it does get you to research and to publications that matter very quickly. Good, next program. We have also these deadlines here for admissions. There's some flexibility, especially if you're not restricted by visa requirements. We can be more flexible and admit you on a rather short notice. If you do require a visa, of course, AUC will sponsor that, but that requires then the usual processing times. Also important here to point out these last 2 bullets on the bottom. If you're even remotely thinking about getting into computer engineering, and you're coming up through the EE program, it is highly advisable to get in this CSE background that is listed here. So this 310, the algorithms, data structures would be critical because in the CEN program, then the algorithms at the grad level will be one of the core courses. And typically for our EE students with an EE background, this algorithms graduate class is a bottleneck. So if you do bring the CSE 310 background, you should have smooth sailing through the graduate program. And the math 243, of course, as well. So if you have a bit, if you can complement, if you go back one more, if you can get the discrete math in, that would also be very helpful, of course. Yeah. Now, contact information, it's me, the program chair, but I also recommend to first contact Lynn and Christina on the data science as our excellent advisors. They know the details much better than I do, and they're always up to date. And so please contact them first, and I can always then follow up and help to get to the right person in case that's needed. Any questions?
Andrew's going to reach out to you and maybe me directly with some questions.
Okay, good.
Otherwise, nothing so far. So students, if you're like, electrical is it for me? I love pure electrical. Then the EEMSE or PhD is going to be for you. If you were kind of like computer science, electrical, I like them both, CEN might be for you. Now, our next program that we're going to talk about from Dr. Pan, our data science, analytics, and engineering program. If you're like, I like electrical, computer science, math, statistics, some more math, optimization, industrial engineering, machine learning, AI, then the data science program might be for you. This is our newest program. It is our fastest growing, and we are very excited. And we just got the 4+1 pairing approved for it within the past week or so. So we are ready for 4+1 students. So thank you, Dr. Pan, for joining us. Would you like to do the slides, or would you like me to do the slides?
Oh, could you please? Thanks.
You've got it.
Yeah.
Let me get that up here.
By the way, I just know the 4+1.
I know, because it like
Thank
literally
you.
just happened.
All right. Yeah. Hi, everyone. I'm Rongpan. I'm reside in the School of Computing Augmented Intelligence, the SKY. So next slide, please. This data science program, especially the master program, is an interdisciplinary program, obviously, and it's a master program across many engineering school and also the School of Math and Statistics. So, why would you consider this program? I would say, like what Lynn said, if you're more into data analytics and statistics, more math, you probably want to consider this program. Obviously, data science is very hot right now. I cannot predict, what the job market will be in 2 or 3 years, but at least right now it's pretty hot. And the student taking this program, typically will learn a lot machine learning algorithm and a lot optimization and also statistics, which probably not the regular courses that you take from electrical engineering. Next slide, please. So the core, this is about our program, and pretty much all the engineering school has some concentrations, data science concentration. So if you are taking electrical engineering concentration, you're still electrical engineering student. So a lot of elective course, elective courses are still from electrical engineering. So there's no much change, but there are some core courses, I think, in the next slide. No? Okay. Now
You want
then,
me to go to that one?
then go back.
Then we can come back, yeah.
Oh, okay, here. Okay. Some core courses we will require you to take basically cover statistics and probability and database and machine learning, those three core courses. You can see some of them from electrical engineering too. So, but you have the flexibility to sample from other schools, like, from statistics or from Sky, computer science, or from information technology in the Poly campus. And then after that, you have concentration course and the elective course. And at the end, you can choose the thesis option or a capstone class, which is FSE 570. It's supposed to be like a applied project type of class. And next slide.
We want to go
Oh,
back
the
to
previous slide. Yeah. Okay.
predictive job prospects.
All right. Yeah, that's kind of um advertising.
It is.
Advertising of this uh, this degree. AI, all the buzzword,
Yep.
AI and the BI. So yeah, I do see it has a bright career, and it's certainly a lot of potential, no matter in your career, professional career growth, or even go further into the research. Is really the top line research area. So yeah.
And that is all the slides I have for you, unless there's anything else you would like to share, Dr. Pan.
I don't know.
Okay.
I hope I give a good
You did.
yeah.
Absolutely. So students, if you were like, I was thinking of being a math major, and then my finger slipped and I selected electrical engineering by happy accident, that might be the program for you. Our innovative, transdisciplinary programs are always changing. I mean, we do see a lot of change while these programs are going on over time. And as students are coming in and giving us feedback and telling us what they need and telling us what they're hearing from employers. So our graduate programs are fluid. If you have ideas, if you think, why isn't this covered? Let me know. Let's see what we can do, because that's one of the cool things about grad programs. So the last grad program that we're going to cover is going to be the robotics program. And I will be presenting that on behalf of Dr. Redcar, the graduate program chair, who wasn't able to join us today. But so computer engineering is kind of the middle of that Venn diagram of electrical engineering, computer science. The data science and analytics and engineering program, that's a little bit of everything. The robotics program is a cross of electrical, mechanical, and robotics. So if you're really enjoying your controls-based classes, your signals and systems, you might want to think about the robotics program. So this is Dr. Redcar. He's not able to join us today. He's an associate professor and associate director for the School of Manufacturing Systems and Networks. So as you've seen today, we have graduate program chairs that aren't in ECEE, but they oversee all of the concentrations. So once again, interdisciplinary MS programs. Are you guys catching the theme of these slides? And noticing how I'm not very inventive with my PowerPoints. They're all basically the same layout. But so the robotics program is across 5 schools. You get to take classes across 5 schools. We want you to learn outside of your program. That's very important to us. We really think that students can learn a lot and just open their minds to something that they didn't know was an option before. All of the majors that ASU has, within engineering, there's over 25 undergraduate majors, and there are over 50 graduate programs within engineering at ASU. So there's probably something out there that you've never considered before, and we want you to think about it. So just like the other programs, you know, what goes into the robotics program? How do we define that? Well, we've got concentrations from electrical, biomedical, AI, systems engineering, and mechanical and aerospace. So that's about anything robotics level. Neural engineering, swarm robotics, mechatronics. There are some really interesting applications going on right now with manufacturing engineering and robotics and optimization for warehouses, transportation, control systems. There is a lot that you can do with a degree in robotics and relating to it. So just like the other programs, there's a couple of set classes, and then you get to pick classes from a very long list. Your core classes are going to be linear algebra and robotics 1. And then you're going to take some controls-based classes, EE 582, and then you pick, what do you want to take? We are really wanting students to create a degree that they are interested in. There's a lot of applications for these interdisciplinary programs. And students often think, well, I want a degree that has this exact word in the title in order to get a job. And that's not really how that works. It's not going to help you all that much. Employers are looking for knowledge and content. They're not looking for degree name. Get a degree in something that interests you and something that you want to do in the future, and that allows you to take the classes that will help you reach your goals. So consider all of the graduate programs if you're thinking about grad school. And that is my very quick pitch for robotics, because I know we are coming up at the end of our time here, and I wanted to leave some time for questions if there are any. So go ahead and put it in the chat or unmute. Let us know. You can always reach out by email. I'll put my email in the chat once again. Always happy to hear from everyone. Let us know how we can help you. Yes, David.
Hello, can you hear me?
Yes.
Okay, so I thank you for the great presentations, by the way, everyone. I just wanted to ask, I heard there was a quantum physics pathway type thing for the bachelor's degree, but does that extend into the graduate's degree, especially if you want to do like some kind of 4+1? I don't know. I've always been interested in quantum physics, and I just wanted to see.
We're working on that.
Okay.
So we have to start with that undergraduate level to create those classes, and then our faculty are going to be able to expand with more graduate level classes. So right now for the quantum area pathway, it is a couple of classes. And then on the graduate side, there's 1 or 2 classes, but it's kind of bleeding over into some controls area, physical electronics, photonics. And you can also take physics classes from the physics department as well within our program. So right now we're a little broad on it. We just need to get some classes developed, but yes, that is coming in the future.
Good to know. Thank you very much.
Yeah, no problem. And so Gia, thank you for messaging me. The EEMSE, so for any of you that are online students, the EEMSE is offered online. That is our only graduate program that is offered online. So if you're an online student and you're like, Lynn has just changed my life and I must be in the robotics or data science program, or I will just die, you would need to come to campus for that. And we can have that discussion of how is that going to serve you? Is this of value to you? And where are you placing the value? Because I want you to make a choice that's best for you, you know, for your goals and for your finances. I'm happy to have that conversation with you. How many 10 graduate courses need to match my specialization course? Choice. 1, that'd be cool. You know, specialization is a loose guideline. It's really, you're gonna probably aim for a job in the future that's related to your specialization. You are not taking all just exactly power. courses. There's more to it than that. We want you to take classes outside of your area of specialization. It is just an internal categorization. It doesn't even appear on your transcripts.
Lynn, I want to add just a brief, it's similar to what the undergraduate pathway theme would be like, where you're getting a kind of a focus, but remember the graduate courses, many of them will take a much deeper look individually. So it's not the same thing, more classes. There definitely is depth to some extent, for sure.
Do I have to pre-select all the graduate classes when applying for the 4+1 program? If you're psychic,
yeah,
you should totally let us know, because that seems like a really useful thing for me financially, because I'd love the winning lottery numbers. Jaya, do you want to talk about
but
this
it
real
is
quick?
tentative. We just need to know that you have the prereqs for the advanced classes that you are selecting. Because as Dr. Kaziki said before, you can't take advanced 525 without having the prior prerequisites in the 491, I mean, 591 or the 400 levels for it. So that's kind of what we want to see. It's tentative because we want to know that that's the path you're planning to take. That can be changed. You can choose to take a different path or not take that course, but tentatively you have to list it. And also, since I have a minute, I would want to say that the Monday info session that is coming up, I plan to introduce the data science program and the 4+1 path towards it, as well as answer all of these questions like how many tech electives you need, all of that. So if you can, please do attend that. Those sessions are not recorded because every semester, every session I provide new information, so it'd be very beneficial to attend. But if you can't, you can always make an appointment so that I can help you further and see how best we can plan your studies.
Absolutely.
Okay.
So the application is partly an exercise
yes,
in understanding the degree requirements. Can 500 level courses be used to satisfy technical electives?
Yes.
Absolutely.
Totally. Yes.
Yes. No problem. You're welcome.
Yep.
Well, we are at time, so unless anyone else has burning question that you need to let us know right now, go for it. Otherwise, feel free to send us an email. Any last words, Bob?
No, Lynn, thanks for running the show. Students, thanks for being here. We appreciate it. And thanks to faculty who joined us. And thank you all. Just a thankful individual.
Thank you, everyone. Reach out if you've got questions. How long is the app? Quick.
Very fast. It depends on how many I have in queue to process and how correctly it's filled. So it could be 5 minutes, could be 2 weeks. So
leave on you, and we'll try to do it quick.
Yes. we will. We will.
Thanks.
Awesome, everyone. Have a good day.
Bye.
Bye. Thanks.